Many people struggle with applying geometrical constraints, and a lot of it is they can be a little bit complicated to use, and if you don't understand them, they won't do what you're trying to do with them, or they'll do something else because you're applying them incorrectly. So we're going to take a little bit of an in-depth look at constraints, which will make 3D drawing much simpler and a lot less aggravating for everybody. So the first one we're going to look at is the coincident constraint. Constraints, like I say, they can be frustrating when you don't understand how to apply them, but when you learn how to apply them and why and what for, they become very powerful tools. So we're going to look at the coincident constraint first, and this one, depending on how you select things, it will do several different things. So if we can select a point or an object, and how we select those things will have a dramatic difference. So if we select this object first and then we select this point, the object moves to where it's in a straight line with that point, but it'll be the lower object because it's the one we selected first. Now if we do the exact opposite, if we select this object and this point, it does the exact same thing in reverse. It moved to the point stayed stationary, the object moved to it, and it became the lower of the two. Now we can also use coincident to select 2 points, and depending on which way we select them, the first one we select stays stationary and the second point moves to it. So that's scenario 1. And if we do it in reverse, we select this point first, select that one, this one stayed stationary and that moved to it. So that's some of the things you can, that's 4 different things without doing anything different. So now we'll come over here and we'll look at this, and we've got just basically a rectangle, and we're going to use the coincident. We can use coincident to move a point to another point, so by locking them together. And since this is origin doesn't move. Typically it's the same way. Whichever one you pick first is going to stay. Your second one's going to move to it, but since this is origin's not going to move, so it will actually let you do it either way, which is new. So we can select the point, select origin, and it moves it to it, and it locks those 2 lines down for us. And another thing we can do with our coincident here is if we have 3 objects such as this, we can select our point, we can select our object, it moves our object to our point, and then we can come along and select another point and select our object, and it moved it right to it. And the horizontal constraints were applied by Fusion automatically. We'll look at them when we get to the horizontal constraint. When we apply the horizontal vertical constraint to a line, the first thing the software is going to do is decide, is the line more horizontal or is the line more vertical? And when we apply it to the line or the object, it's going to, so that applied the horizontal constraint, so it followed the X line in our drawing, the X direction. And when we go to apply it to a vertical line, if the line's more vertical and we select the line itself, it's going to rotate around the center into the more vertical position, but it follows the Y or the Z depending on which plane we're drawing on. So other things that we can do with this, so if we pick our horizontal again, horizontal vertical, and we select the 2 points on the end, so that's our first point. When we select our second point, it's the second point's going to stay stationary and the first point is going to move to either the horizontal or vertical position. The same if we select them the other way around, it does the exact same thing, but the first point we selected moved and the second point stayed stationary. So then in the case of our horizontal line, it works same way. If we select this one first, it'll move to match our second selection. And if we do it the opposite way, select this one first, it'll rotate into the horizontal position to match the second point we picked. So that's how the horizontal constraint works. So the vertical constraint and the horizontal constraint work identically. So concentric, with the concentric constraint, whatever we apply it, whatever circle we apply it to first will remain in place, and the second circle will move to it. So if we select this is our first and this is our second, it moved in that way. If we do the opposite, if we select this one first, this one second, the second choice will move to the first. And in the case of an arc, we can pick our first object and then our second, our arc. We pick our first object and then we pick our arc. The circle moves to the arc. The circle will always move to the arc. Doesn't matter which order you select them in, the circle will always move over to the arc. With the parallel constraint, the first object will stay where it's at, but the second object will rotate to have the same angle as the first. The second object will always rotate around its center. So, very simple constraint. The tangent constraint is a very useful, powerful tool, and it will constrain two objects to keep a point of tangency relative to each other or their extension. So what that means is if we come down here, we select our circle, we select our line is going to move to where it's tangent to the circle, and it's always going to move the line, not the circle. You also need to use this whenever you want to place circles tangent to each other. So we can grab our tangent tool, we can pick our circle, and then the second circle we pick, notice its center point, that's not going to move, but the size of the circle adjusted to meet the other. And the same will happen if we apply the constraint to another circle, and it's simply going to adjust its size to meet, but the center points stay the same. That may or may not be what we want it to do. So if we want to prevent them from changing in size, we have to dimensionally constrain them first. So we can just apply a dimension to each, and then when we apply our tangent constraints, the center will actually move. So the first circle we pick, the second will move to the first, and we can repeat this. The second will move to the first, and notice that the way they are moving is slightly different, but this time they keep their sizes. So that is how we can deal with whether we want the circles to keep their size or not. The perpendicular constraint can work one of two ways. So in this case, we've already got a line that's horizontally constrained. So if we add the perpendicular constraint, it's going to move the one that's not. So it'll create a 90-degree angle from the first one. So if we don't have one constraint, if we remove the horizontal constraint, the first one we select will stay stationary, and then the second one will move to be 90 degrees with it. And if we do that the other way around, so the second one you pick is always going to move, the first one you pick is always going to stay the same, as long as there's no other constraints involved. So pick our first line, pick our second one, pick our collinear constraint, pick our first line, pick our second one. It moves to be in a straight line with the first one. If we do the same thing with this one and this one, it just continues. If it had been higher up, it would have probably left a little bit more distance in there, but that's how that one works. The symmetric constraint will constrain two or more curves or points on objects so they maintain symmetry around the selected line. So we need three objects to do this, so we can pick symmetry, we can select our first object, we can select our second object, and then when we select our symmetry line, it moves them to be at the same angles. Sometimes it does weird stuff to the sizes, but that's how that one works. The equal constraint will constrain two lines or polyline segments, arcs, circles, to be equal to each other. So if we use our equal constraint, we can pick our first line, and when we pick our second line, so there it made both of them equal. So we can do the same thing with circles. We can tell our circles we want them to be equal, and now we have two equal sized circles. We can also do it with arcs, but the arc will stay the size it is and the circle will always change. to match the arc. So that's how the equal constraint works. The fixed-unfixed constraint will constrain a point or a curve to a fixed location and orientation in the world coordinate system. So what that means is if you apply it to here, this is where it is, and that's exactly where it is. The constraint should only be used if you can find no other way to constrain a very complex object. It will make the math significantly more complex, which can cause failure to resolve errors. Notice that when we use the fixed-unfixed constraint in our C-clamp lesson, we always moved the object to origin first, which can simplify the math and allow it to function correctly. But this is something that you don't want to ever use, unless, which is our fixed-unfixed constraint. You don't want to use that unless you really need to, because an object's simply too complex. It applies constraints for us. They may not be exactly what we want, but that's why we don't choose it.